Okay, I'm going to remind you real quickly what we talked about a few days ago. Just as a quick reminder about how to multiply fractions, we talked about saying, hey, if we've got something straightforward, like 2/3 times 4/5, I can easily just multiply across the top, multiply across the bottom to get 8/15. In this case, that actual fraction does not reduce, so I leave that final answer. But as a reminder that's listed off to the side, we always do need to simplify the fractions. So remember, when we think about rational expressions, we're dealing with a polynomial over a polynomial. You can see that linear function over the quadratic, the linear function over the quadratic. And ideally, you know enough at this point to think, by looking at that right away, okay, I need to factor. So my first step, always, just like the way we did over the past few days, is to factor. This factors nice and cleanly, x plus 1, x minus 1. I'm multiplying over here. This also is a difference of two squares, just like x squared minus 1. This is going to be 2x plus 1, 2x minus 1. But as a reminder, and we talked about this when we looked at multiplying fractions the other day in class. First of all, think about this as a factor, almost as if there's a coefficient out in front like 1. You don't have to list it, but it is untechnically or technically there. So I can immediately start to what we refer to as cross-cancel. This 2x minus 1 can cross-cancel with that 2x minus 1. This x plus 1 can cancel with that x plus 1. And this simplifies to a very nice, clean 1 over x minus 1 times 2x plus 1. Now, I'll remind you, when we list the restrictions, we have to list it from the non-canceled form. So I'm going to list -1, 1, -1/2, and +1/2 as restrictions. So you are looking here at a basic multiplication of rational expressions. What I want you to do now is just on your own, take a minute, and we're going to just go back to straight variables to kind of warm up on your own here. Do that exact same concept. Multiply either across the top, across the bottom, or cross-cancel and multiply across the top, across the bottom. And go ahead and put the recording on pause, and when you're ready, check your answer. Okay, so on this one, I like to go ahead and I think it's actually just as simple to say, okay, this is 30, 5 times 6 going across. X to the 5th comes from the summation of those exponents, and y to the 3rd is also on top. On bottom, I have 20x y to the 4th, and then I must reduce. So I'm going to say right here, 30/20 reduces to 3/2 by dividing both by 10. I have 5 x's on top, 1 on bottom. That leaves me with 4 on top. And I have 3 y's on top, 4 on bottom. That leaves me with 1 y on bottom. From the non-reduced form, I'm going to state that x cannot be 0 and also y cannot be 0. Again, following that same process, look at the next one. If you would for me, please, go ahead and put the recording on pause, and when you're ready, check back. Okay, so you want to make sure, per the example that we gave, that we take a 4x out. You're left with 1 minus x. When I factor that numerator, again, just as a reminder of factoring, I can always multiply back in to make sure that I have the original form. I've got x plus 3, x minus 1 for my factored form on bottom. On top, in the right-hand fraction, that factors to x plus 3, x minus 2, and on bottom I have 4x. Again, if you're forgetting the restrictions, to go back to the original form, one place you could add it in would be right here before I ever start to cross-cancel. X cannot be -3, x cannot be 1, and x cannot be 0, but check that out. 4x's cancel. It's going to get a little dicey here in a minute. My x plus 3's cancel, and it looks as if this is done. So we would go ahead and write 1 minus x times x minus 2 all over x minus 1. And where this gets a little more challenging is in this next step. You'll notice how close these two factors are. In fact, they're so close that the only thing that is different about them is that they are exact opposites of each other. In the top one is positive, and the bottom one is negative. In the top, x is negative, and the bottom, x is positive. So if you think this through, I I actually can go a step further with this reduced form. How would I do that? Well, if I think of unfactoring or undistributing, I can essentially take a negative 1 out. When I do, I would be left with negative 1 plus x, or rather x minus 1 times x minus 2 all over x minus 1. And now, this simplifies to a very nice clean negative 1 times x minus 2. Obviously, the same restrictions that we already listed apply, but that's a little bit more sophisticated step. Realistically, you probably didn't add in the last step, so we want to make sure, rewind if you need to, and add in extra work if you need to your notes, but go ahead and make sure that you're in good shape there. If you need to, put the video on pause. When you're ready, go to the next slide. The next thing we're going to talk about is dividing rational expressions. This gives you a nice layout there. You can read through that on your own. For now, on this slide, just in the upper right-hand corner, I'm going to remind you what we talked about the other day. When I take 2/3, and I can either write it like divide by 7/8, or it might be written as 2/3 times 8/7. It doesn't matter. The idea is that I have to turn this division into the multiplication of the reciprocal. So this ends up being 16/21. I want to emphasize there is not an option as to which fraction to flip. You flip the one on bottom, or in this case, the one listed second. If you need to, write that in a sentence. You have to flip, and can only flip, the one on bottom or the one that is second. You're not given an option. You don't get to pick, and you do not, under any circumstances, flip the first. You will get an incorrect answer that way. That said, when we look at number 3, I'm going to list this right away as 6x squared plus 7x minus 3 all over 6x squared. And I'm going to immediately flip this. So this is 7x over 2x squared plus 3x. Now I'm going to show you a little bit of strategy as you look at these. One is, when I look at 6x squared plus 7x minus 3, I do not quickly see the factoring. So oftentimes I will use what's there in the denominator of the other fraction to help guide me. Here's what I mean. Notice in this denominator, they both have an x, and I'm left with 2x plus 3. When I go and I look at this other fraction, I'm going to play with that a little bit. And I'm going to try 2x plus 3, because keep in mind, rational expressions in Algebra 2 are really manipulated expressions. We often give you ones that will factor cleanly and will cancel with other factors. So if you think about it, what would go here to give you 6x squared, 3x? What would go here to give you 1, or to give you negative 3 would be 1. This would have to be negative. Check it. That's 6x squared, that's minus 2 plus 9. That gives you the positive 7x. Keep in mind, these are they won't always factor like this, but they often will. This 2x plus 3 is gone. Then you have an x here that can cancel with that x there. This 3 can go into that 6 twice. Oftentimes it helps to circle what you have left. You have a 3x minus 1 on top, a 2 on bottom, and an x squared on bottom. Your final answer is 3x minus 1 over 2x squared. As per our usual, we have to clarify from the beginning what is a restriction, but keep in mind that this comes from that actual original fraction. So that means automatically x can't be 0. Over here, x can't be 0, which we just listed. And then when I flip it, I also know x cannot be negative 3/2. So with that in mind, we're just jumping to slightly more challenging ones on this in this concept. So go ahead on the next one. When you're ready, hit pause, and then come back, and we'll talk through it. Okay, so order of operations says that when I have multiplication and division in the same line, I go left to right. So I'm going to go ahead and write this 2x squared plus x minus 6. And left to right means I'm going to need to multiply that first. 2x squared plus x minus 6 times x minus 2 all over 2 times 2x squared minus 2x minus 60. You can already see where we're going to need to factor. Then I'm going to multiply by that reciprocal. This x minus 6 goes on top, and on bottom I have x squared minus 4. So you can tell right away we're going to have a decent amount of factoring. I'm going to factor to see if I can get 2x squared plus x minus 6 to factor, which I can. You got a 2x here and an x here. You can play around with this a little bit. Just for time's sake, you should have 2 here and 3 here. I've got a positive 1 in the middle, so that will be positive. That will be negative. And I'm left with x minus 2 on top. On bottom, notice I can take a 2 out of that. It'll attach to that 2. I have a 4 here. You'll be left with x squared minus x minus 30. And I'm going to go ahead, even in this line, normally I would suggest putting a whole new fraction, but I'm going to go ahead and list x minus 6, x plus 5. Over here, I have x minus 6, not a coincidence. Also, x plus 2, x minus 2 is in the denominator, and watch what happens. First of all, for the record, you could easily, or perhaps maybe a better word would say, go back to this right away and list the original restrictions. Why? Because this is telling me x can't be 6. When this is factored down here, we know x also can't be negative 5. So keep that in mind as we start canceling things out. X minus 6's cancel. I've got x plus 2, x minus 2 that cancels. And I also just like to circle what's left. So I've got a nice 2x minus 3 here. I've got a 4. And I've got an x plus 5. So I've got 2x minus 3 all over 4 times x plus 5. The good news is I've already listed all of my restrictions from the beginning. X plus 6, or sorry, x cannot equal 6, x cannot equal negative 5. But also as a quick reminder, when that second fraction flips, I know x also cannot be negative 2 or 2. That is the conclusion of division. We're going to now go into what is a combination of these skills, adding and subtracting from the other day, multiplying and dividing from this lesson. If you need to, go ahead and pause the video now, do the multiplication and division portion of your assignment, and then once you're done with that, then come back to complex fractions. Okay, so on this slide, we have what's referred to as a complex fraction because I have a fraction in the numerator. Anytime I have a fraction in the numerator or denominator, I have what we refer to as a complex fraction. When I have that, I could think of it as 2/3 divided by, 2/3 divided by 4. That's one way to think about it. So you could actually think of this as 2/3 times 1/4. Cross cancel, this will give me 1/6 as a final answer. But if we start to think of this a little differently, I want to talk to you a little bit about another way to see this. See this as 2/3 all over 4. The only mathematical equivalent step that we are allowed to do without thinking of it as an equation that keeps the expression legal and equivalent is multiplying by something that's equal to 1. Well, if I multiply the top by 3 and the bottom by also 3 because that is equivalent to 1, that will help me. Why? Because what I don't like about a complex fraction is having a fraction in the top or in the bottom. Well, what is 2/3 times 3? It's 2. Multiplying by that denominator here and here, therefore the combination of these cancels that denominator. I'm left with 2. What's on bottom? I'm left with 12. Basic multiplication of fractions. What does that reduce to? 1/6. With each of these, I'm going to talk about different approaches. Pick a way that you like best, stick with it, but I'll typically talk about them from 2 ways. So for example, when I look at 1/2 plus 3/4 divided by 1/8, take about 30 seconds, talk through either on your own with, you can talk to yourself if you want to. You can either work on it on your own or talk through it with somebody right around you. Put it on pause and then give it a shot. Okay, so 2 approaches. One would be to go ahead and say, hey, listen, you know what? I know how to add fractions, and I do that by finding a least common denominator. In this case, I'm going to go ahead and take 8, which technically is not the least, but it matches down here, which is going to be nice and clean. How do I proportionalize, again, my made-up word, how do I proportionalize 1/2? That becomes 4/8. How do I proportionalize 3/4? It becomes 6/8. All over 1/8. Watch how clean this becomes. This is 10/8, then I'm dividing by this fraction, I'm multiplying by the reciprocal. This is just simply 10. But some of you may hate adding those fractions. So look closely at 2, 4, and 8. They all go into 8, so go back to our previous slide if we need to, but if you multiply by something equivalent to 1, that would be 8/8, the common denominator over the common denominator. When I do 8 times 1/2 plus 8 times 3/4, all over 8 times 1/8, do not miss that all the denominators cancel. On bottom, I simply have 1, and on top, I have 4 plus, and 8 times 3/4 is 6. Same answer. That is 10. Now, for the most part, I'm going to encourage the top option of your skill set because that's going to be the one that most people like and it's easiest. But always know you can always add them. Moving forward, you're welcome to do both. I'll often show both, and when we're in class together next, I'll show both. But for now, go ahead and we're going to stick to this top style when I explain. We're going to go ahead and move into one with variables. We're going to do this one. I'll show you this one, and then you can go ahead and try letter D. Notice you have as denominators xx and x plus 1. And from our earlier conversation about adding or subtracting, our common denominator is x times x plus 1. Now, don't miss this. On top, I will multiply by that common denominator, but this is only legal if I multiply it in both places. In both places. Now, if you want to write out the distribution step the way I showed before in the previous slide, you're welcome to do that, but here is the deal. When this denominator goes here, the numerator is going to be proportionalized with x plus 1. And the second numerator is going to be proportionalized with x. On the bottom, you have that top numerator proportionalized by x plus 1. Now, this is not done, even though we'd like it to be. This is on top, x plus 1. This must be simplified. This is minus x squared all over 3 times x plus 1. I should always rewrite that quadratic to double check to see if it is factorable for time's sake. I'm just going to tell you it's not. We talked already in class about how to find if it is or isn't. Since it is not factorable, that is a final answer. In your last problem, will you go ahead and pause on the video and try letter D, and then we'll go over it together. Okay, if you would like to stick to adding or subtracting, you're welcome to do so. And I'm happy to, next time we're together, show you more of that style. For now, because it is simpler, I'm going to show you the process of multiplying by something equivalent to 1. That something needs to include the common denominator of all the fractions, which in this case is x minus 4 times x plus 1. On top, that 3 is proportionalized by x plus 1. On bottom, that 1 is proportionalized by x plus 1, and that 3 is proportionalized by x minus 4. On top, I have 3x plus 3. Now, I am going to argue, actually, you can go ahead and keep that. Since there's nothing else to combine it with, keep that in factored form. Don't distribute it. Here, because this is not in factored form, I have to distribute. This would just be obviously x plus 1. This right here would be 3x minus 12. So that gives me 3 times x plus 1 on top. And on bottom, I have 4x minus 11. Now, there is nothing else to do in that denominator, but for the record, your final answer does have to be factored on top. One thing we didn't talk about in the previous example that I want to just remind you, these also have restrictions. So x cannot be 4, x cannot be negative 1. And in the final answer, and this is where this is a little unique, x also cannot be 11 fourths. So that may be something you run into over the next couple days. I'm just going to remind you, hopefully what the sub did, which is that you have an assignment over these 3 topics. There are about 7 or 8 problems per section, multiplying, dividing, and complex fractions. Those 3 also have an answer key that's already posted to Schoology. They need to be done and checked by Monday. By Monday, the addition and subtraction entire worksheet should be done and checked, as well as the problems that are posted on Schoology and hopefully the sub gave you. You do not have to do all of the problems on the 3 worksheets, just the ones that are listed on Schoology, and make sure that they are checked. All right, my friends. Thanks for hanging in there. I will see you on Monday. Have a great weekend. Thanks.